Hi, welcome back. Uh, so hopefully most of us are back from the break. And yes, we were continuing with the last exercises that were in this section. And so the next one um, was, I don't know if you had any trouble, but I'll go through the solutions just in case, because it's worth highlighting a few bits and odd behaviors of making slices and arrays and how I'm manipulating those slices. Um, so the next exercise is around thinner slices, and what's basically asking you is what will happen if I were to do this. Remember, I defined my element array before as a string. So if I were to do this, it will print nothing, which is to say that it's an empty string. And that's because I'm asking it to start from element 3 and to go to the same element. So no elements to store. Um, Now, for example, say that I want to do that with my data array. I will print something, just a couple of square brackets, and but it's trying to tell it's an empty array. Uh, what if I were to print something, try to extract something like this? And what would you expect it to print? Uh, so in this case, it will still be an empty array. However, if we were to try to print what type of data is, hopefully it's the right amount of, yeah. So it's an, yeah, if I were to try to print the shape of those empty arrays, we might find something slightly odd. In the first one, when I requested say element 3 to element 3 in the row, element 4 to element 4 in the columns, and was printing out just a couple of square brackets, and it's telling me that the shape is 0. So 0 rows and 0 columns. However, in the next one, I keeping the rows 3 to 3, but I am requesting all the columns available. And if I print the shape, the array I get it's still empty because it has 0 rows, but now it has space for 40 columns, which can be a bit odd because suppose it's still empty. However, this can be useful when working with other functions that expect arrays to have a certain size, even if they are empty. Just something to have in mind, because it can be a source of all kind of very fun error messages. Next one is about stacking arrays. Uh, so in this exercise, what it's asking us is there are a couple of functions from NumPy that allow us to manipulate our arrays in different ways. So let me. It's asking us is to define a few arrays, and we can do this like this. So before, what we did to define our number array, it was done by us for us by a function, the load txt function. It loaded the content of a text file and saved it into a numpy array. But we can do this manually as well. And the way to do this is with this in this way. So you would need this parentheses, that's because it's a function, and inside you will need to add the type of array you want. So if it were a one-dimensional array, you can just use as one set of square brackets. But if you want a two-dimensional array, we need to use two sets of square brackets. So this one would be the first one, the external set of brackets, and then internally, and this will define the rows, and then we will separate the columns with another comma, and then 4, 5, 4, 5, 6, and 7, 8, 9. So I'm trying to define an array that has 3 rows and three columns. So if I were to print this array, I can do this. Try to give it a piece of format. There you go. Print A. You will see something like this. If we go ahead now, numpy.array. So here I will simplify the first function. So it's stack, and this function, what it does, it stacks horizontally the arrays I provide. And so it's a function, so I use parentheses, and then I need to provide in which the way I want my arrays to be stacked. So I will use the previous array I defined, array A, and what hstack is going to do is going to stack them one next to the other. I'll show you how that is done by printing it. So you can see I have the A array 1, 2, 3, 4, 5, 6, 7, 8, 9, and next to it I have the same array. But what hstack did, just put it in the same array, just one next to the other. And there is an equivalent function called bstack, which you will expect it takes more or less the same inputs, and then it will stack them vertically. So we'll do something like this. And it will, as we were expecting, we'll put one. I will put A on top of A in a single array. So now, what the dark exercise thing is asking us to do is to try to manipulate the columns of A so that we only the first and last columns are stacked in a 3x2 array. So that is what we are requested to do. And so based on this, we could try to do it. So let me define a new one, numpy dot, and I want to say I want to do it like this, hstack. I want to stack them horizontally, and as we saw before, we need a couple of arrays. So I will select. Actually, let me just to make sure I'm extracting. No. I want the first column first. So I want all the rows and the first column, and then next to it, I want the all the rows and the last column. So that would be 3. 0, 1, 2. There you go. Yeah. And let's see if that works. And kind of, I guess. What he says is that I had columns. I had the values 147. You see here my A array. I had the first column 147, and then the last one 369. But this is not in the way I was hoping it to have it. It's sorted in a just single column. So the problem is that what is happening is that when I do this, I'm trying to extract or sprint the first column of A, because it has only one dimension. It has only one dimension, one of the axes, and it is dropping it by default. So it is supposedly it should be a 3 by 1, and it's dropping that 1, and it's only giving me the 3. So it's a 3 one-dimensional array with 3 elements now. That's the default behavior of NumPy. If we wanted to keep the shape of this column, we will need to force NumPy to do that. There are a couple of ways in the training material in the solution to do that. The one I find it easier is to specify that this is actually an array providing those square brackets, so that I want to preserve that additional index. So if I do that, you'll see that it tells me it's an array. But if I do it in here, let me show you what will be the impact of that. And hopefully I'm adding the right amount of brackets. And no, it's not. This is actually it's beginning to work a different way. Let me what expected. I didn't work as expected. So let me do this instead. So let me use one of the solutions in training material instead. So by specifying this symbol when extracting only one column, I will tell NumPy that I want to keep this index. So if I do this in here, hopefully, and now NumPy will allow me to keep the right shapes, and then they will be stacked in the right, expected manner. It's not something to have in mind, because when working with arrays, and if you extract one column and want to do some operations with it, like matrix multiplication, that can actually be problematic, this default behavior. It can be difficult to track where's the source of the problem, because if all the operations seem to be correct, if you don't know that NumPy can have this kind of on the side effect, it can take some a bit of grief to try to find what was happening. The next exercise is about tracking the change in inflammation in the data. NumPy has another very interesting function called diff, and that what it tells you is allows you to keep track of the difference in the input data between different elements. That will make more sense if I explain what I mean. So let me try to create a new variable that to hold the data for patient 3 for week 1. So I will need to extract the third row, and I want all the columns from 0 to 7. So I do that and I print that variable. I get this value. So I have 1, 2, 3, 4, 5, 6, 7 entries. That is the information values for this patient. I can call my NumPy function diff and provide it with an array to work with, patient 3, and this will be the output. The training material is a bit more explicit. What are the operations that are we are doing here? But you can probably do the same. So the first element is the difference between the second and the first. So 0 minus 0. The second element is the difference between the third and the second. So 2 minus 0, and so on. And if you realize we only have six elements, which kind of makes sense because of the operations we are doing. So that can be useful. For example, if you need to working with some kind of numerical derivatives, something like that, can have some application there, or just want to keep track of just the magnitude of differences. So I don't know if you have any doubts up to this point. Do you find the slices working with NumPy arrays? Do you have any doubts to that? Because the next couple of sections that we're going to be exploring today, we're going to be making heavy use of these concepts now. Not, should probably start with the next section, which is about visualizing tabular data. So this is the first section where we're going to actually, we're going to start printing some images, and for that we're going to start using a new library in Python. So there is no plotting library in Python. There are several, but I think probably the de facto one, the one that everybody uses, and most common one is Matplotlib. And Matplotlib have several different, say, sub-libraries within it, and one of the most common ones is pyplot. So we're going to be using that one in this course. So the way to do it: import matplotlib pyplot, and once as we did with NumPy, once we have imported that library, that gives us access to a new set of functions on top of the default Python library functions and the NumPy function that we already imported before. Now we will have access to a new set from Matplotlib pyplot. Matplot, and I will need to call a specific function to plot the data that I have, because it's a two-dimensional array. There are, again, different type of functions that are more suitable to print different type of arrays. So this one in particular, we will see in a moment what type of plot it creates. And I need to specify that I want to display it. So if I run this, it will take a couple of seconds, and it will. If everything went well, you should see something like this. This is kind of a heat map of my data array, and it's showing 60 rows by 40 columns. And what this means is the brightness of the different pixels is the magnitude of the inflammation. So brighter colors means higher levels of inflammation. Darker colors are lower levels. So it does seems like there is some kind of trend. There is apparently an increase towards the middle of the recording period for all patients, at least that. And that is something interesting that we have realized more easily by plotting the data. And you see, it was not too difficult. We did that in 3 lines, and we already have a high level of understanding, hopefully. But we can do more. So let me now try to save the average level information on a new variable. So we already know how to extract the average or the mean values. And we're going to be doing this for we want to calculate the mean value for all days. So we need to do it over the patients. So we're going to be running this the calculation over axis 0. And now I'm going to access a new function. So before I was using imshow to create a heat map because it was a useful function to plot a two-dimensional array. It wouldn't make much sense to do it for a one-dimensional array, so I will use a new one called plot, and this one will create a very simple plot. But still, I need to tell matplotlib pyplot to show it. And you see, it was fairly simple. So as you remember, this bidding here returns a vector, a one-dimensional array, and the next couple of lines is just telling matplotlib that I want to create a plot out of that vector of that one-dimensional array, and then just display it. There is more to it. You can read the documentation. There are several more options about how you can control how the plot looks. You can add labels. You can resize it. You can change different aspects. We will be looking at some of them, but there are many. So you can save it as well. We're going to be doing that. So you want to use the image for some report or some paper. Let me continue doing the analysis of the pie plot. I want to create a new plot, but next time I want to use the maximum values for all across the days. So for each day, I want to find the maximum value. So numpy.max data, and I will be doing the analysis over the x-axis, over the patients. So that's axis 0. Lay pie plot dot show. And you see here, this time I didn't create a temporary variable as I did before with the average information variable. I can just do it in a single line in here. I can just request the one-dimensional array directly in here and feed it to the plot function for from matplotlib in one single line. So avoiding creating an extra temporary variable. And we'll create this figure. And equivalently, we can do that for the minimum value. And okay, that sort of give us the same feeling that we did with the original heat map. There is some trend towards the middle of the of the recording period, but some oddities in here. For example, it does seem like there is a linear increase towards the middle in the maximum values, and then a linear decrease towards the end, which seems odd. I would I would expect linear behaviors in patient data. Also, there is a lot going on here. These step functions. Yeah, you will expect some kind of a step functions because the information data are integers, which is fine, but this kind of what slope between the lines, that is also weird. So it might be good to try to further analyze what is going on here. But before doing that, it can also be good to try to create save some of the script commands that we have been using so far in a different script to be to facilitate their reuse for in the future. So let me create a new document. And go to file. We'll create a notebook. And I will try to, so the Jupyter notebooks is very good to, start typing commands and seeing what they're doing. But once I'm kind of more or less satisfied with a set of commands that I think do what I want to do, it is good to try to put it in a different file or script that I can just run and have the same output every time I run it. So I've been using NumPy, and I've been using import matplotlib. And if I remember correctly, I need to import, well, not load the data. This is the command that we use. And data information. There you go. Uh, now, now, once I have the data, I want to create the figures again. So there are. This is a good point to show you how to give it a format, to put all the different figures together, grouping them in a single plot. And yes, that's a good point. Thank you for highlighting that. Yes, we do need that. Otherwise, you won't use anything by default. Limiter. You want to see if you were paying attention. So the way to have to group the different plots is by using one of matplotlib functions called figure. This is kind of a canvas where you will specify how that region, different aspects of that region. And one of those is you can specify the size. And this is supposed to be the units, the default units that I believe are inches. But obviously it will be resized to the screen that you're using. If you were to display it in your Jupyter notebook, right? So this command will give you this region where you're going to plot different subplots. In those subplots is where we're going to plot the figures that we created before. So, and we're going to be doing that by using this function. So now that this region will be saved into this variable, or this variable will help us reference that region that we just created. So we will use that reference here and add it a subplot. So these numbers, what do they mean? So we're asking, we want to add a subplot to this region that we just created, and the way to do it is we're going to provide it to this function how that region is arranged. So meaning how many rows and how many columns it has, and in which index we want this subplot to be added. So I'm saying it has only one row and it has 3 columns. So the region has 1 row and 3 columns, and I want this subplot to be placed on the first slot, which kind of makes sense because my figure has 10 by 3. So let me copy this. Oh, sorry. And amend it a bit. And I want the next figure to be put in the second position, and third figure to be put in the last position. Now, and now that I have, so this will create a reference to the subplot, and we'll save it into this axis 1, and so on for. Oh, sorry, this in the chat. Sorry, somebody put it in message. Oh, no worries. happens all the time. Yeah, so we're saving the reference to this subplot on this variable axis 1, and the same goes for the second subplot and the third subplot. And now with that reference we can manipulate the subplot. So in this case, for example, I can add a new label to that subplot, and I could call it average, because that's where the average is going to live, and I can add some other, and I can obviously I up to this point I just have specified the positions of where those plots are going to live, and but I need to specify what I actually want to plot in there. So so now I can do the same for the other two subplots. So let me do this for the next one. So subplot 2, and I will push the max value, and I need to max. So I'm just taking advantage of the structure is very similar, so I just meant some of the bits are different. Mean and right. So now I have defined what the different subplots are going to contain, and there is another layout function that corresponds to the canvas, and this function what it does is kind of tells Matplotlib that use a default amount of padding between the figures. If you look at the documentation, you can see that through this function, you can modify the canvas so that the different subplots are, you can modify how separated they are among each other. For now, we're going to be using the default values. Plot save figure, and here so once we have defined the canvas and the different subplots and what those subplots are going to be, what data are going to be showing, we can actually tell Pyplot as well that I want that figure to be saved, and the Pyplot, and I want to show it as well in here in this Jupyter notebook. So if I made any mistake, which is likely, I will go ahead and try to, yeah, it worked. That's good. So it printed this these three figures next to each other, which is good. They look pretty. And also, hopefully, if I jump to my first tab, I will have a new figure in here, well, a new file, which is inflammation.png, and if I open it, yeah, I open it in my browser, so that's good. You can see it. It's the same figure, so I can use that to add to some Word document or a PDF document, so for some kind of report. So that's kind of useful to share the analysis with somebody else. Right now, so far, if you realize that I'm doing a lot of typing because I'm importing NumPy and then importing matplotlib.pyplot, and after that I need to use NumPy dot and then the name of a function I want to access. And there's a question that says, is there a way to save the script written directly from Jupyter Notepad? Yes, there is. Yeah, there is. So you can go to File, I believe. You can type Save As, and that will save the Jupyter notebook. But you can, you can come here I think it's download as. Yeah, I think it's in download as. You can save it as a Python script. Hopefully, I don't know if that's highlighted. Yes, it is. And there are other formats in which you can save this. So that is very handy. Yeah, thank you for the question. So I was saying, so if I import matplotlib as matplotlib.pyplot, I need to use the same name every time. I need to use matplotlib.pyplot, and then the actual function I want to use, which it works, but it's very time consuming, especially when the function the name of the library is very long. So I can do this and as this, for example. I can import the library and then give it a nickname. And there are some in the Python community. There are some already agreed nicknames for several very common libraries. So, for example, you will see very often you look for help in forums that people import NumPy as NP, or sometimes they just refer to NumPy not by its name NumPy but as NP, and everybody understands it because kind of now everybody wants to know about it. And you could import, for example, matplotlib.pyplot as PLT. But if we do this, then we need to use that name everywhere now. So, otherwise, we will probably get an error. And yes, there should be one. PLT. Yeah, I know. So if you type Control F, but that's the search function from I remember there's one. Find and replace here and edit. So yeah, there's one. Yeah, sorry. The thing is, if I were to use all the different shortcuts of Jupyter Notebook, probably I would be going too fast. Might defeat the purpose of a introductory course. Yes, so if everything went well, this should work. And let me see. Yes, I get the same output. But now, obviously, this will have been much easier or faster to write because I just need to write the 3 characters instead of the whole very longish name of the library. Right, there are a couple of exercises in the material. This is asking us about doing some plot scaling and doing some straight lines and making your own plot. Probably you can take a few minutes, maybe it can give you 10 minutes to go through these exercises and modify the short script that we have created in here, and see if you can change the aspect of this of these plots. So let's go ahead. Give you a few minutes to work on that. So it's 12:15. So give you 10 minutes, and we can go to the solutions at 12:25. There you go. Excellent. Right. So the exercises is asking us to do some manipulation with the figures that we have at the moment. The first one is asking us to do some plot scaling plot scaling. If you notice by default, we didn't provide any limits to the different plots, but it seems like Python, that the matplotlib kind of understood, give us a defaults, and pretty good defaults that shows more or less the whole of the data that we had available. But what if we wanted to highlight different sections, or if we wanted, for some reason, perhaps we want to keep the same limits to different plots in order to be able to better compare them among each other. So we can do that with one of the functions. So let me go back to my script, and in here I will add another function, set y limit. So this will provide the limit in the y direction, and I can define it in here. So the first one will be the bottom limit and the upper limit, and I'll go into 6 units in here. So if I type this, and I can see now that I have changed the limits of my last year from 0 to 6, and I can do the same for the others if I want it. Now there is also what happened if the data changes, right? I don't want to keep manipulating this, I don't want to keep modifying this number necessarily depending on what is the database, what is the content of the data in this particular file. So I can probably try to do it in a more automatic way, like say, let me save the data that I want, that I am plotting. I will cut this bit and paste it in here, so that I will be saving this array of minimum values in this variable, and I will like here, so that will be the same effect. But now I can use this array as well to automatically find what is a suitable value for the bottom limit. So I can use numpy.min to find the minimum value among the array of minimum values. And numpy max, what is the highest minimum value. Oh. Data. So hopefully it kind of makes sense. Right, but maybe it's too close to the, if the maximum value, the highest minimum value is 5, then maybe it's too close. So maybe it's better if I give it a bit of headroom. Yeah, that looks better. So now it starts right at 0. So that's good, and I can do the same for the others. And now this also is it will automatically detect whether the right values for the limits based on whatever the content of this file is. I don't need to change it manually anymore. So that is good. Now another bit that we mentioned, I mentioned before, it was that in the third figure and also in the others, there's this weird odd behavior that you have these lines that seems to be you have some kind of slope in here, which is weird. But you wouldn't be expecting this because you only have integer values. So you definitely would expect step functions, so meaning going from 0, then straight up to 1, then straight up to 2. That's fine. But here you have some kind of slope. So the problem with that is that it's because it's the default matplot kind of style from the time of plotting. this data, but the folder will kind of interpolate any points between two given entries, given elements, and that's what it's doing. We can ask Matplotlib not to do that by providing one argument to my, let's say, let's keep working on the third subplot. The axis at the time of plotting is where I want to modify this. So I'll do throw style, and there are several options. You can probably take a look at the documentation for a more thorough list. But for now, let me use this one, and you will see what is the impact. Now that changed the look. Now Heatmap makes more sense because you don't have any values there that between the 0 and the 1. That's more or less what you would expect it to look. And we can add the same option to the other plots. Let me just copy it and add it in here as an argument, as a second argument to the second plot and then to the first plot. And hopefully, yeah, let's change the look of our plots. The next exercise is asking us to create a new plot. Now this time with the standard deviation. So we more or less saw how to do this already. We can save it. PLT. What is the name? PLT. Yes, PLT. Plot. And as we did before, we just need to specify what is the data that we want. Dot standard and the data, and we will be looking in x and the 0 axis. And then PLT show. And we do that hopefully. Yeah, and it's giving us the same kind of a weird slanted line, so we can, let me copy this argument and paste it as a second argument in here and replot. There you have. And the last exercise is asking us to move the plots around a bit. Right, it's asking us that instead of having the three next to each other, just to put to put them on top of each other. So we can do that by rearranging a few bits in our script. So you remember, this is the line that controls the shape of our plotting area. So at the moment I have, this is the first field is the width, and then the second one is the height. So I can probably swap those. So then this time will be 3 inches width by 10 inches height. And if I do that now, it will make sense that now I have more rows than columns because I have more space in the vertical direction. So I will use 3 rows, 1 column, and this will remain the same. It will be the first element, and 3 rows and 1 column, and 3 rows and 1 column. Yeah. And yeah, that should be everything that's needed. Yeah, there you go. That works. I can actually change how it looks if I wanted, because I have more space in here. I can probably use 5 perhaps, and yeah, it looks better, I think. So yeah, that's how quickly you can change more or less your speakers look. Right, any doubts up to this point? Not sure if I'm going for the right speed. Try not to go too fast, but not too slow. Please let me know if you have any questions. If not, let me go to the next topic. Probably this would be the last one we can cover in the available time. So I will come back to my. I will create a new notebook. So far we have been working with NumPy arrays, but also Python by default it has a similar functionality and allows you to work with lists. And then a NumPy array is kind of a list, but they work in slightly different. They work in similar ways, but they also have some bits that are different. I'll try to show you. So right now I don't have Python in this notebook. We'll be just using the default list provided by Python, by the default Python. So let me create a list of elements. So 1, 2, 3, 5, 7, and this is my odd numbers. So as we expected, this will print the list, and we can access the elements of the list as very similar as we did with the NumPy arrays. First element, the square brackets, and if I do that, that first element is 1, and I can add, for example, the second element. But just remember that these are not NumPy arrays. This should be 1. These are just lists, default Python list, so you don't have the same functions available, like minimum and maximums that you have for NumPy arrays. So yeah, but you can access the single elements, similar manner, and you can store different things within them as well. So you can have a list of names, for example, 3, and Darwin, doing, and right, yeah, the type was on purpose. So we just print the list, and names not defined. Yes, names. I'm not using the right name of variable name. There you go. And probably I realized I made a mistake. Say I wanted to change an element, and if you remember in one of the previous lessons, is that you can access individual elements of a string. So we could access, for example, print names 1, that's Darwin, and we could try to access individual elements of that string. However, we wouldn't be able to change it. Like, for example, if I wanted to change that value, say, if I wanted to name to set it to something else, that will give me this kind of error, which means that this operation is not supported, meaning I cannot change a single character and a string. And the problem with that is something that can be also one of those differences with other programming languages, is that strings in Python are considered immutable objects. So there are two types of objects. One is mutable, meaning that you can change their value, and other are immutable objects. And strings are one of those type of objects. So once you define a string, that string is saved directly in memory, and Python won't let you change the value. You can redefine the whole string. For example, if I wanted to say names 1, that is Darwin, I can change it for Darwin, for example, and I want to print again the names. Let me copy this. It will change the value stored. It will replace the string, the whole string, but you won't be able to change individual characters within that string. That's something worth considering. And also another important concept is that lists are reused by default, meaning they are saved in memory, and if you make copies of a variable that holds a list, both variables will point to the same place in memory. And if you change the list in one of those variables, the other variable will also be impacted. Let me show you with an example. So let me create this list of how to prepare salsa. Preparation for the lunchtime. So I have this list, which is fine. 4 elements, and those elements are strings. Now I will make a copy. Salsa. There you go. Okay. Now, say I want to replace one of the elements of my original list. Now I want to use peppers. I want to use hot peppers. That's how you create a salsa. And now let me just print one of the ingredients in my salsa. Salsa. You might not expect that any elements in my salsa have changed. However, I did modification in my original salsa recipe, salsa list, after I made a copy in my salsa. So I was expecting, you could have expected that my salsa will keep the original list, but that was not the case. When I modify this list, also my salsa was modified. because both lists are pointing to the same kind of to the same place in memory. There is a way to create a, make a real copy, say, or duplicate list in different places in memory, but you need to tell Python specifically you want to do that. So let me. There's a question in the chat. You cannot save the element of a list by copying it. Not by default. Not in the way that we would expect it to work with other variables. We will need to use this keyword to specify that we want to create a different copy in memory, and that will be for all purposes a different list. So let me now to repeat this command, but now this time I am telling Python to create a separate list, and this time, yes, my salsa has the original copy, the original list, with all the peppers, and not the hot peppers. That's something that can be a bit, not expected if you didn't know about it. So, right. Yeah, as I mentioned before, what is also, yes, it will work in the same way, or should work in the same way. So let me. Are there pointers in Python? Oh my god! Yes, we're moving to more advanced topics now. In the same sense as in C or C++, or that's what the question you're trying to get at, or? Yes. References in memory. Don't know. To be honest, I haven't used anything similar pointers in Python yet, so I wouldn't say there are not. But somebody in the chat says that there are not. So I haven't seen any. Right. So just probably just want to show you as well how to access a nested list. So you can also create, as in NumPy, arrays and a set of nested lists. So lists within lists, because you can hold you can put different type of variables, different type of elements within your list. You can put also lists within lists. So the way you do it is like this. So, for example, so this will be a list, and then another element. So this is a list, and then I want another list. And the second element of my second list. Okay. And the name. So I have 3 lists in one list. And if I wanted to access specific elements, I can do something like this. And that will give me extract one list. But perhaps I want to keep the shape, or the external content, the list within the list. But just, because of the format, because the format is useful, I can keep it like that. So a list within a list, which is external brackets, by adding these bits, these external brackets, at the time of requesting it. And you can access elements within that list in this way. The first element. And yeah, something different from NumPy arrays is that you can have a heterogeneous list, meaning that you can, for example, have a list that has numbers, but also mix it with some strings, and that will work. That not necessarily might work with NumPy arrays unless there are special symbols like NA for not available data. But with the full Python list, you can easily do this. And you can modify the list. Simple. Let me just recall my list, my first list with odd numbers. You can modify that list by adding some values to it. And if you do, dot and the tab key, you can have access to the different methods that you have available for Python lists. So I will be using the first one, which is append. And what this method does is it will append one number to the end of the list. Like that. And there are other type of functions, methods that are available that let you manipulate the list. There's another one called pop, which lets you remove elements, specific elements from the list. And now, after I pop the element out, the 0 element, now my new list is 3, 5, 7, and 11, and my remove element, the element they popped, is 1. And there are, several different. Sorry. Oops, sorry about that. I wasn't. I'm not expecting any package. Reverse. And this reverse function will should reverse the order in which my elements are sorted, but partly didn't. I believe perhaps it's because I should save it. Reverse There you go. I think I might have done it twice for some odd reason. Right. I think right. We can show you a bit more. More other things you can do with the lists. You can slice them as well. Like for example, nominal name. You can, if you have a something like this. Let me just copy this directly from. So it's kind of a complicated name for me. So we just copy it from directly from the training material. Drosophila melanogaster. You can slice it in a similar way that we did with the NumPy arrays. For example, if I want to just extract, I think the first listed group, and you can do it in that way. And you can keep manipulating it with more, like you can, for example, bring the species. And yeah, you get the idea that it's very similar to what we have done, just that this is not NumPy arrays. It just have similar functionalities. And probably it's I think it's almost one. So yes, I think there are some exercises at the end of this section and there are a lot of more material where you can explore more advanced features, like working with for loops, if statements. So the next bit that is worth going through probably later on in your own time is the script that we have so far to print these figures. The next step is to try to expand it to work with all the different CSV files that we have in our data directory. So at the moment we only working with the 01, with the first file that we have, if you remember here, but we have many more, and we would like to extract data from them as well and process it. And for that, it will be useful that instead of running this script 12 times, maybe using a for loop to go through the different the different files that are in the directory, and do some processing automatically. For that, you need to use some for loops, and then take some decisions based on the content. So yeah, please take a look at the material that is available. Fortunately, we have only 3 hours for this session, so I don't have any questions. Do you have any questions at this point? Can we make executables with Python? It can be coupled with make automation. Not executables per se, as you will maybe like with Fortran or C++, but you can have scripts, as we did in the first on Monday. We had 3 different Python scripts that were called by make, and those scripts is just text files with some Python instructions, and it's really Python who is going to interpret what the different instructions are that are written in the script. So you could easily use this script in here, save it as a Python script, as a text file, and have Python executed, and then have that as a rule in your make file, for example. So yeah, that's one way to do it, to integrate this this script that we have written with make, as we did in Monday's lesson. Runtime input as arguments to our Python script. Yes, that's possible. That we need a yes. I'm more experienced with how to create the. I believe you use a library for that. So, sorry, I don't have it from the top of my head. Yes, this is module. Yeah. Thank you, Timothy. And I believe that's also contained in the training material. So just a bit concerned about if anybody else has to be somewhere else, because we schedule the end at 1 p.m. Please feel free to leave the session. Thank you for joining. Thank you for joining today. Yeah, hopefully, at least I give you some of the very basics. Thank you.